Welcome to yet another video offered by EduPen channel. I am Dr. Badela, and in this video basically what we're going to be doing is collision calculations. So basically there are two types of collisions. You have elastic collision and inelastic collision. So with elastic collision, it's a type of collision in which both momentum and kinetic energy of the object are actually conserved. So it means that the momentum before the collision and the momentum after collision are actually equal. And then secondly, you have kinetic energy. So the kinetic energy in elastic collision, it's conserved as well. So it means that the kinetic energy before the collision and kinetic energy after the collision is actually the same. And then when we talk about inelastic collision, it's a type of collision in which the momentum is conserved, but the kinetic energy is actually not conserved. It means the kinetic energy before a collision occurred is not equals to the kinetic energy after the collision has occurred. So without any waste of time, let's get right into the question that we have. So as I've mentioned in the previous videos, I always emphasize that you should always outline the information that you are given so as to minimize the chances of you actually making mistakes. So without any waste of time, let's get right into the calculations. So we are told that a truck of mass 4,500 is traveling at a velocity of 20 meters per second and it hits a car from behind. So the first thing that I'm going to do is to write all the information that I am given for the truck. So it's going to be the mass, which is equals to 4,500 kilograms, and we are also going to have the velocity, which is equals to 20 meters per second. And then I'm also going to write the information that I was given again. It says that the car has a mass of 1,000 kilograms and was traveling at 15 meters per second. So I'm just going to write the information about the car and say car, its mass is 1,000 kilograms and its velocity is equals to 15 meters per second. When we further read the question, it is said that the two vehicles now connected carry on moving in the same direction. So it means now they have become one thing. They are no more separate cars. We no more have a truck and we no more have a car after the collision. So they move as one system. So it means we get to actually combine their mass, and also the velocity will also be like the same for both of them in terms of calculations. So without any waste of time, let's get right into the calculations. So the first thing that you actually need to do before you actually calculate anything, you need to check if your information that you're given is actually in the correct units. So we know that in momentum calculations, we actually use mass in kilograms, so it is okay. And then we also use velocity in meters per second. So basically, if you check this question, you are actually not told whether the collision is actually inelastic or elastic. So the safe way to actually perform your calculations, it will be to use momentum formulas in order to calculate the velocity. Because if you use kinetic energy formula, you are not sure whether the kinetic energy is actually conserved or not conserved in this question. So because momentum is actually something that is conserved in both inelastic and elastic collision, it is safer to use which formulas? To use the momentum formulas. So without any waste of time, let's get right into it. So we are going to say P total momentum, initial total momentum is equals to PT final. So if you do not know how to calculate the total momentum of a system, please refer to the previous videos on this channel. There's actually videos about calculations of total momentum, so be sure to refer to that first and then come to this one when you are done with it, so that you get to understand like why we are saying this, why am I writing this like this. So initial total momentum is composed of what? It's composed of two things. It's composed of the momentum of the car before the collision and the momentum of the truck before collision. So basically, I'm going to say MV, I'm just going to say MV1 plus MV2, which is equals to MVF. So the formula for momentum is actually P, which is equals to mv, where your m is the mass, the v is the velocity. So this is going to be the momentum for the car, and this is going to be the momentum for the truck, or vice versa, however you want it. And then for this one, it's actually going to be the total momentum of the system after the collision. So I did not write MV1 and MV2 again because we are told in the question that they are now connected. So it means that they are actually one thing. That's why I only wrote MVF. Okay. So we substitute the information that we have. So let's start with the information about the truck and say that MV1 is actually going to be the momentum for the truck. So we have the mass for the truck. It's actually 4,500 multiplied by its velocity, which is 20, and then plus the momentum of the car. So we are told that the mass of the car is actually 1,000 multiplied by 15, which is its velocity, is equals to. So when it comes to the right hand side, you are actually going to add the mass of both the truck as well as the car, because they are now one system and they are connected. So when we add those two, we are going to have 5,500 multiplied by the velocity that we do not know, because this is actually what the question requires us to calculate. It is said that calculate the final velocity of the system. The final velocity of the system, the truck-car combination after a collision. So you actually continue and do your calculations. So we have 4,500 multiplied by 20, which is equals to 90,000. 90,000 plus 1,000 multiplied by 15, 1,000 multiplied by 15, which is equals to 15,000. 15,000. So you go to the right hand side, you have 5,500 VF. So basically what we're going to do is that we are going to add 90,000 to 15,000. So 90,000 plus 15,000 is 115,000. 115,000, which is equals to 5,500 VF. And then you divide by 5,500 on each side, divide by 5,500 on each side, and then your VF is going to be equals to 105 105,000 multiplied by divided by 5,500, which is equals to 19.09 meters per second. So that is the velocity of the connected system after the collision. So after the truck and the car actually hit each other, they then moved together at the velocity of 19.09 meters per second. So we then continue to the next calculation, number B. So number B says that determine the kinetic energy of the system before and after collision.